Ich bin ein Studenten, Mechatronik-Studenten an der Hochschule Karlsruhe und jetzt bin beschäftigt mit diesem Projekt Drais 3D von 3 Ländern, Malaysia, Äthiopien und Deutschland. Von unserem Team, wir haben 7 Leute, 2 von Äthiopien und 2 von Malaysia und die anderen sind aus Deutschland. Und dann in Malaysia, wir haben noch ein Team, die von 3 verschiedenen Ländern zusammen sind. Und dann in Äthiopien, wir haben ein großes Team von Äthiopien. So this is our first iteration, the first design that we made. Okay, then we have this version that we made afterwards. So it's a continuous improvement process, and this is our final model. So as you can see, this is the render, the 3D version, what we expect our Draisine to look like in the end. So it will look something like this, and here we can see honeycombs, triangles, all of these are research and not just aesthetics, they are there for a purpose. It's lighter, it's stronger, and it's better. So how do we create our parts? Like I explained, here we start off with a CAD model. We start off with a CAD model, so this is designed in a computer, and then we transfer it to the printer set software, then we slowly print it out. So this might take a few days sometimes for every single part, and here is one of our parts, and we join them together with glue and bolts. And these are some of the processes we use. We use sandpaper, we use this soldering iron to smooth it out, to make it look better for the end product. And then so for 3D printers you can expect something like this, and this is our team. So yeah, that's it. What you're seeing right now, this is the front fork of our Draisine, where the front wheel will be attached here, and so it will be vertical like this from top to bottom. Alright, and your wheel will go through here. Then your steering will be up here. So what's interesting about this fork is how did we combine this fork together? Water now. So alright. So what are you seeing right now is the joints that we designed for this fork. So these are inspired by mechanical joints from Japanese, where they built houses without using any nails. So what we did is we created these kind of structures so that we could combine them easily without using any extra nails, and we just use glue and they will stay strong together. So this material is made of PLA. It's a kind of thermoplastic where you melt plastic and it will just print out lines by lines and to form layers by layers into this final product. So this is a front fork. Right now here you can see this is the chest rest. So what you do is when you ride the Draisine, you'll be laying down like this and your steering will be right in front. So it's made out of 3 parts. So this is one of it. This is where your chest rest will be. Next, we have a support structure and also this honeycomb structure. So this honeycomb structure is specially designed so that we could reduce the materials being used here, and as well it still maintain its integrity and still strong, very strong. So how do you combine 3 of these parts together? Same, is inspired by mechanical joints from Japanese, and we just put this here and we combine this together and it will be strong. Yep, so that's it for our parts, and we're still expecting more parts upcoming which are still printing. This project, the goal of this project is to promote sustainability in 3D printing, and we want to know the potential of 3D printing for the future, and we want to reduce the manufacturing cost of these bicycles. So 3D printing is a good way to manufacture complicated parts and also increase the performance of these bicycles through 3D printing. So we can achieve more designs through 3D printing on bicycles. So I can imagine that the future of bicycles will be all manufactured using 3D printing.